This is a talk about prototyping APIs and why it's a good thing. If I could sum up this talk in one slide, then it's this: an ounce of practice is worth a ton of theory. Not really sure who said that. The internet doesn't seem to know, so I've attributed it to everybody I could find. Hopefully it's already clear or become clear how this applies to prototyping. But before we get into the specifics of that, I want to kind of start by discussing design and prototyping as concepts and what they're kind of reviewing what they're for and what their benefits are. So let's start with design. Design is a model of reality. So it's the map, not the territory. It's something that's much quicker and cheaper to kind of create and change than the actual thing that you're building. The idea being that you can sort of quickly iterate on a design and improve it and eventually get it to a state where you think it's good. And designs are primarily validated by inspection. So we can look at them and we can say, or at least estimate whether a design will fulfill certain criteria that we need to fulfill when we build the thing for real. So contrasting that with prototyping, prototypes are realized objects, but with some limitations relative to the kind of the production object that we're likely to build. Again, we make trade-offs in order for them to be quicker and cheaper to kind of iterate on than the real production item. But the crucial difference from a design is that prototypes are validated through use, through real world use. So all of those things that we kind of abstract away when we make a model of reality, we can kind of uncover through the use of a prototype. So let's talk about design and prototyping in software specifically now. So design kind of has had a bit of a bad name in software, sort of maybe since the agile movement. The idea of kind of big upfront design has fallen out of favor. It's something that we think of as being emergent and evolutionary and expressed by code, rather than it sort of being a specific activity and set of artifacts that happens before software is built. But there are some exceptions to this, and that I want to give an example that's not APIs initially, which is UX. So the impact of poor design in UX can be very high, and as a result of this, sort of particularly over the last 10 or 15 years, maybe the use of UX design has become kind of routine in software. It's table stakes for shifting a software product. So now let's talk about design and prototyping in APIs, and we're starting with the motivation for them. And I would say it's APIs and UX actually have a lot in common in terms of the motivation for wanting to do some design up front. And also there are some sort of unique properties to it that APIs have that I think serve as further motivation. So for one thing, design decisions that you make with APIs have to be lived with for a long time. Whereas in a piece of software where we kind of control all sides of it, correcting poor design decisions is relatively cheap and painless. But if we're putting an API out there, and particularly if it's one that we're selling to our customers, then the impact of getting it wrong is something that is felt for a long time. We can't just go and change the API design sort of week on week, because we'll make our paying customers very cross. Like with UX, poor design limits adoption. If you're selling an API product, like if you're selling any kind of software product, poor design is likely to drive your would-be customers into the hands of your competitors. So this is not something that we want to do. And even if we aren't selling our APIs to customers out in public, so if we're doing a microservices architecture and our customers are internal and therefore kind of obligated to use our APIs, we still impose a productivity tax on everybody using those APIs if we don't design them well. If we make it hard to understand our APIs, if we make basic use cases difficult to achieve, if there's a lack of consistency, all these kind of things. And another final thing that's somewhat unique to APIs, we have this kind of serial working problem, and this is particularly acute in kind of internal API situations, or maybe where APIs are being used to enable a partnership between two businesses. We we want to ship features as quickly as possible, but where there's an API in the middle, we tend to have this way of working where we have to go and build the API and get that to a good state, and then the consumers of the API, the mobile web data, whatever other services or apps are being built on top of that, the builders of those have to wait for the API to be built and shipped in some form before they can ship anything, and this creates this inefficient serial way of working between teams or between organizations. So let's zoom in on API design a little bit. So API design, I think, is reasonably well established as a practice now, and there are a number of well-known products on the market that help with design. A number of big vendors, most of whom you've probably come across at Apidays, that make tools that are enable kind of collaborative API design, I suppose. That they predominantly revolve around collaborative kind of editing and review, and various other activities around open API or some similar kind of specification document. And like we talked about earlier, designs are verified by inspection. So in this case, API designs, we have design review by human beings. We have linting and other kinds of governance tooling and rules that we can apply to our API designs, and we can inspect, and we can kind of estimate the suitability of the API for use by our customers or users. And undoubtedly, this helps produce better APIs. But this process tends to add time and effort up front, and like we talked about before, APIs tend to cause this sort of serialization of work anyway. So when you add an extra kind of design phase onto the front of the work that needs to be done to ship something, then this can further push out our lead times. And I think this produces the kind of pushback that probably happened quite routinely 15 or more years ago in software shops around UX. We don't have time to do this. We don't have time to go through this sort of a number of design iterations before we even start coding. We just need to get something out there. I suspect this still happens a lot in APIs, far more so than it does in the UX space anyway. And like we say, sort of design is verified by inspection, but API design, like other kinds of design, doesn't have a verification through use mode. And this is a particularly important thing in software. When we're building software, anyone who's done it for any length of time will know that an ounce of practice is worth a ton of theory. As soon as you sit down and start coding and start using something, that's when you learn a whole load of lessons that hours and hours standing around a whiteboard analyzing won't reveal. So being able to test the design through use is really important, and the earlier we can do that in our sort of software delivery life cycle, the better. So this is where API prototyping comes in. It solves two of these key problems. One being it enables this early validation through use. An API prototype allows consumers of that API to start testing it and verifying its design before it's committed to production in some way. And it also allows this parallelization of development. So consumers and producers can go off and work on realizing their parts of the product in parallel, rather than consumers waiting for producers to finish shipping something. So with that, I'm going to talk about a few different ways in which prototyping can happen. Some of them are sort of things I've observed people doing in practice, and some of them are things that are both that and things I would recommend doing. I'm going to start with something, an approach which I've come across anecdotally a lot. I don't think the people doing it would necessarily call it prototyping, but I'm going to call it code a bit first API prototyping. And essentially, it's just this: you write just about enough code to get some kind of response for an API route. So you have route models, all that kind of thing. You probably mix the code in with your existing production code, and you ship it into a test environment. And this sort of short circuits the process a bit, because it means that you don't have to write a full working production implementation of the code with business logic, persistence logic, all that kind of stuff. And this is probably better than the alternative, which is waiting until you've shipped a full production implementation of something to find out that the design is wrong. But it's still quite a long cycle time. If you're iterating on design ideas or design refinements, then you still have to go through this code test, checking the source control, let it build in CI, let it go through your CD pipeline to deploy. And even if that process is pretty slick in your organization, it's still quite a long lead time to iterate on design changes. The other downside of this approach as well is it's fine when you're just kind of, like I've done here, kind of returning a basic hard-coded canned response. But if you want to start showing some sort of more nuanced behavior, more variations in behavior, then you can get into this sort of spaghetti of if statements and temporary code that you then end up sort of progressively ripping out as you go on. And it's not really a great experience, or one that's sort of optimized for building good simulations of APIs. So next up is mocking. So WireMock, my company's product, is based on WireMock open source, which is one of a whole host of API mocking tools. There are open source ones, there are commercial ones, sort of SaaS and on-premise flavors. Lots of these out there, and all of them will allow you to build a prototype through stub responses, or whatever their languages to describe kind of request response pairs. And this is good because you can do it far more quickly than you typically can with a sort of code deploy test kind of lifecycle like I described in the previous slide. You can change things sort of virtually instantaneously with most of these tools. They often have a load of primitives that allow you to kind of build up more sophisticated behavior simulations more quickly. So you can sort of represent variations in behavior in your API rather than sort of purely the basics without writing lots of messy code. But on the other hand, the design and prototyping isn't the primary use case of these tools. I would conjecture, maybe some would argue otherwise, but they're still kind of somewhat disconnected from other, in particular design tools. So where we have design tools that work with API models or specifications or whatever you want to call them, and enable all of that really valuable verification by inspection, mocking tools that tend to be fairly disconnected from that. In practice, this means the ability to generate specs, or be able to sort of work hand in glove with specification and mock is kind of lacking from these tools generally. So I should also mention kind of starting the other way around. So another way you can do prototyping, I guess, is to start with an API design, but generate mocks from the API design. So a lot of the sort of major tools in this space have some kind of mocking capability that will take typically your open API spec and will generate a mock from it. And this seems superficially like the solution to the problem. You have an always synchronized mock server and design. You don't have to do a lot of work to keep these two kind of singing in harmony with each other. But you tend to bump into the limitations of this approach sort of fairly early on. So open API and description languages like it are not designed for generating mocks from. They lack a lot of the information you need in order to represent that kind of rich set of behavior that I was talking about before, that when you're sort of working in the native language of mocks, you can express. So unfortunately, when your mock is wholly generated from an API description, you tend to have the same problem from a couple of slides ago, where you can represent the very basic sort of rudimentary case perfectly well, but as soon as you want to kind of go off to the side a little bit, then you have more trouble, or you simply can't represent those cases. So in summary, the mocks generated tend to be simplistic and can only be used so far for sort of serious testing and exercising of the design. So It won't surprise you to learn that WireMock Cloud, my company's main product, is specifically designed with API prototyping in mind, and it sort of brings together sort of a number of the things that I've talked about in previous slides, and kind of puts it all together in one platform that makes this workflow easy and practical and scalable up to complex systems, lots of teams using it, that kind of thing. So first up, it's at its core is a flexible mocking engine. It allows lots of richness in terms of how you match requests, in terms of how you generate responses, all of that kind of thing. So you can express a good breadth of behavior, or simulate a good breadth of behavior of your API. Crucially, it supports this bi-directional spec and mock generation. You can bring in existing specs and start with them, and then prototype on top by building mocks. And as you prototype, that will generate back into your spec again. So you have this very sort of labor-efficient way of maintaining a mock and a spec in tandem with each other, but without losing the expressiveness of the mock being a distinct artifact. And finally, because mocks are a useful artifact to maintain in the long run, beyond the sort of initial prototyping phase, and you want to make sure these things stay in sync with each other over time, it has this traffic validation feature. So this can be used to make sure that your open API, your mock responses, and your client are all agree with each other, all agree with the open API spec. And in fact, you can even use this via proxy mode to validate traffic going out to your real API implementation as well. So when the producing team have built a real implementation of something you've prototyped, you can use this approach essentially as a contract testing strategy to ensure that your real API and your mock and your open API and all of these things are all sort of in compliance with each other. And that's all about all I have to say. So I'm hoping if you've taken nothing else away from this talk, then you'll take away the fact that prototyping APIs enables verification through use. It shifts discovery of design shortcomings earlier in the timeline, so you can correct them far more cheaply and be more productive. And then it gives you a further productivity enhancement by parallelizing producer and consumer development. So when discussing this with your organization's management, you can say we can deliver in a shorter timeline rather than longer because of the benefits of this parallel producer consumer development. And that's it. Thank you very much.